Hello, I'm Rian Currie, a third-year student at Humber College in the Electronics Engineering Technology program, and this is my capstone. It's an electronic load designed for 60 volts at 10 amps, so 600 watts. The boards were designed and laid out in KiCad, both the boards and the schematics, of course. The case was designed using a website called MakerCase, and the files that website generated were modified in Fusion 360 to include these vents on the sides as well as the back. One of the challenges of this design was cooling the MOSFET correctly, which is what dissipates the power. So the way I solved that problem was by purchasing a HP server CPU heatsink, which has an integrated fan, which is controlled by this fan controller I purchased off of Amazon. It's temperature controlled as well, so at no load, the fan is at low speed because the heatsink is cool. When it heats up, the fan speeds up. The load is controlled using an Arduino Nano, and it has a 2-channel 16-bit ADC and a 12-bit DAC. Both communicate with the Arduino over I2C. The LCD is also controlled over I2C. The rotary encoder here has a push button, and the keypad here is also hooked up to the Arduino. Both the encoder and the keypad are just hooked up to regular GPIO pins on the Arduino. Alright, so this is the DC electronic load. Takes 12 volts in, 2.1 millimeter barrel jack. Plugs into the back. Turn the power switch on. Wait for it to boot. Now, connect to the power supply using the front panel banana jacks. Press the star button to zero the meters. This meter down here is measuring voltage. This is measuring current. And the power supply is just off to the side here. Now it defaults to constant current mode. The keypad, the numeric section, is not implemented currently. Load on and off is done by the pound symbol. Mode A is constant current mode, which we're already in. Mode B is constant power mode. Mode C is constant resistance mode, which isn't quite implemented right yet. Now if we turn the output of the power supply on, it's set to 10 volts and has a current limit of 3 amps at the moment. As you can see, 10 volts is displayed correctly by the electronic load on the LCD. Now, to change the position of the cursor, press the encoder. It can be incremented by turning the encoder. The load can be turned on, again, with the pound symbol. As you can see, it displays the measured current being drawn, the voltage at the terminals inside the unit. It calculates the power as well. Here is the measured current. And the measured voltage, which I'll take the top cover off for, is measured down here. As you can see, it's fairly accurate. Switching to constant power mode, it automatically turns off, turning it back on. It's also relatively relatively close. Here is the fan controller, the power input, the MOSFET board with the sense resistor, the heatsink with an integrated fan, the main control board, the amplifier board, rotary encoder, the keypad below it, the main input terminals below the main LCD.